Good morning, students. Today, I'm again with you with a new neat question. Let us see what is the question. A colorblind girl is rare because she will be born only when there are four options. Her mother and maternal grandfather were colorblind. Her father and maternal grandfather were colorblind. Her mother is colorblind and father has normal vision. Parents had normal vision, but grandparents were colorblind. Okay. So before going to solve this question, let us discuss what is color blindness in brief. Students, we see millions of colors all around us whenever we open our eyes, just because of the presence of three types of cone cells in our retina. Namely, the cone cells are L cone cells, that is long wave cone cells, M cone cells, medium wave cone cells, and S cone cells, that is short wave cone cells. Okay. Now, any defect in any of these three cone cells leads to a reduced perception of colors, and that condition is called color blindness. Okay. When all the three cells are functioning normally, we see all the colors of the world, and that condition is called trichromacy. Tri means three because three cone cells are working, functioning normally. Okay, so trichromacy. Now, color blindness is of three types, namely red-green color blindness, blue-yellow color blindness, and total color blindness. Okay, so color blindness, color blindness is of three types. Okay, what are the types? One is red-green color blindness. Second is blue yellow color blindness, and the third one is total color blindness. Okay, this red green color blindness is very common. Okay, and this is due to reduced perception of shades of red color or green color. Okay, and this defect is due to the defect in L cone cells or M cone cells. Okay, and this is very common. Blue yellow color blindness is due to defect in S cone cells, and this is very rare. And what is total color blindness? Total color blindness means if all the three types of cone cells are defective, then that condition is called total color blindness, and the defective person or the person with that defect is unable to see any color around this world, and the world is black and white for him or her. Okay, now let us move to the question now. Okay, so a colorblind girl. Okay, how a colorblind girl can be produced when the girl is colorblind? Remember, colorblind is a sex-linked inherited disease. Okay, and the defective gene is linked or found in X chromosome. Okay, suppose this is the daughter, okay, or the female child. We know that female has a pair of X chromosome as a sex chromosome, and in case of male there is one X, one Y chromosome. And if the gene is linked with this X chromosome, okay, so for color blindness, for this is colorblind daughter. Okay, so for this girl to be colorblind, there must be a defective gene, okay, on X chromosome, both the X chromosome. Why so? Because if only one X chromosome has the defective gene and other X chromosome is normal, then in that case she will have normal vision. She will not be diseased, but she will be called carrier. Okay, but to be colorblind for this daughter, there must be a pair of defective alleles. Okay, so in both the X chromosome, there must be one defective allele. Okay, now what will be the parents of this daughter? Okay, suppose this is the mother XX and this is the father. How the sex of this girl is determined? This is determined by these two X chromosomes, and these two X chromosomes are from one from the mother, okay, one from the mother and another from the father. Okay, so if an X chromosome has come from the father, then this X chromosome must be with defective gene. Okay, and one X chromosome from the mother, then there must be a defective gene in one X chromosome of the mother, at least one X chromosome. Okay, now you see, then the mother will be carrier and the father must be colorblind. Okay, this is colorblind. Okay, so for a colorblind daughter, the father of that daughter must be colorblind and the mother should be either carrier or colorblind. Okay, because one of the X chromosome has come from the mother and another X chromosome has come from the father. Okay, so this must be the condition. Now let us move to the options. The first option is her mother and maternal grandfather were colorblind. Okay, her mother is colorblind. All right, we need that. And her maternal grandfather were colorblind. Okay, maternal grandfather means this. Okay, this is grandmother, this is grandfather. If the grandfather is colorblind and grandmother is not specified, okay, then we will take the grandmother as normal. In that case, the mother will be carrier. All right, okay. But here it is written that mother is colorblind. Okay, if mother is colorblind, that means there must be at least one defective gene in grandmother also. In this case, now the mother will be colorblind. But in this option, nothing is given about the father. And we know to be a colorblind daughter, the father must be colorblind. So this option is not satisfying. Okay, this option is not satisfying. Now go to the second option. Her father and maternal grandfather were colorblind. Okay, father is colorblind. All right, we need that. And maternal grandfather is colorblind. If maternal grandfather is colorblind, then the daughter will be either carrier, okay, or colorblind. If the grandmother is also colorblind, then in that case she will be either colorblind or carrier. Okay, so this option is quite satisfying. Okay, we are getting either this condition or this condition, and we are getting this condition also. Father is colorblind, it is given here. Her father is colorblind and maternal grandfather is colorblind. So this option is quite satisfying. Now move to the third option. Her mother is colorblind. Mother is colorblind, all right, and father has normal vision. No, this is not possible. If the father has normal vision, then the daughter will be either a carrier, okay, or normal daughter. So this option is also not satisfying. Now move to the fourth option. Parents have normal vision. Parents have normal vision. There is no defective gene in the parents. But the grandparents were colorblind. No, this is also not possible. If the parents are normal, okay, they have normal vision, then in that case what will happen? Suppose the mother is carrier, she has a normal vision. But if the father has normal vision, that means no defective gene is present. So in that case, the girl child will born with either a carrier, okay, with normal vision, or she will be normal. So no colorblind daughter will be produced. That means this option is also unsatisfying. So what is the most satisfying answer here is the option 2. Her father is colorblind and maternal grandfather is colorblind. So the option 2 is a correct option here. I think you have understood this. Thank you.